I'm Michael, and I'm working for Bosch, obviously. And Bosch was already mentioned many times. So what we're doing and what we're working in the Eclipse IoT, also having some people in the working group like Kai Hudala, who is doing a lot for it. And yep, what I'm doing all the days is keeping the IoT up to date, hopefully. So this is Benjamin mentioned that our IoT suite is based on many Eclipse IoT projects, and one of them is hawkBit, and we make a commercial product out of it. And I'm Germany, had a long trip here, actually. Arrived yesterday, a little bit jet lagged, so maybe if I'm blagging out. So I want to start a little bit with why we need actually software update in the IoT, because I think many projects don't start with it. Many projects start with implementing features and connectivity for sure, to start with. You cannot connect anything. Oh, let's do it later. And so why it's so important? So many people of you here are developers probably, and they have IoT solution probably already up and running, maybe operating it, maybe developing it. But how many of you guys have a software update solution for their IoT solution? Yeah, one, two, three. Okay, how many people have an IoT solution? 1, 2, 3, a little bit more. Okay, there are some people who have IoT solution and not yet and software update solution. That's maybe good. So let's start. Why we need it? So everybody remembers in October 2016 there was a big outage of the internet and Twitter goes down and everything. So devices get hacked and there are so many security. You see it on the news all day. There's another security patch and another hole, another exploit. So. And devices increasing and increasing in the IoT. So it's very, very important we keep them up to date and fixing all the security issues, right? So if your solution gets hacked and all your devices are hacked and, I don't know, going crazy, that's bad news. So another thing, what's very good at software update, if you start with a project with it, and we have many projects at Bosch, and the first thing I said, most of the people, they don't start with software updates, but it's actually an enabler to really have agile development. So if you have the basic settings, you have the connectivity, and you wanna update your software with new features, with security patches, it's very convenient if you can just do it from your desk, and not like, I know many projects that go with a USB stick from device to device and to a charging station and update them with a USB stick or an industry assembly line. So you can do everything from your desk, right? You can update all your devices. You don't need to send somebody out there. And there are also a lot of challenges in the software update mechanism. And one of I want to just show you 3 of them. And one, it's security. So your device is probably protected to not overriding any software on it, especially only one thing because you have a software update solution, and this is allowed to update your device. So what if your update solution get hacked and you have a legal way to update new software and maybe malware on your device? That's really bad. So security is one of the key features which you need to protect your software update solution, right? And another thing is API stability. If you're producing devices or other products which get connected to the internet, they're not connected one day or 1 week after you produce it, right? Devices, they're lying around, they have a long development cycle, they're lying around a warehouse and the customer is not plugging in directly, so maybe they are years in a warehouse and a customer plug it in. And what if the device is old and is not able to communicate with your application because you are updating your application? So software update is the one API which always needs to work, right? You can fix everything with software update. So this is what we are also doing in hawkBit. We never break APIs because you cannot break it in a year, you cannot break it in 5 years. So because you never know when the next device is getting online. And as Benjamin mentioned, and there are so many IoT devices out there, and it's growing and growing, and many people start connecting things like crazy. So you need to be able to scale them out. Not only your device management, so not everybody can download the software at once. Not 1 billion devices can download the software from a server, right? This will break your bandwidth, your internet connectivity. You need to scale them out. You need to group them. You maybe want to also group them by an alpha system, a test system. You want to do a software update on a small basis and then growing up. And we came up with the solution of hawkBit. So we started this project January 2016. Our initial contribution, we had a proposal, as Benjamin mentioned, how it works in the Eclipse IoT group. And we started our initial contribution in January 2016. And Kai Zimmermann, he's not here today, but he's the project lead. And we are working at Bosch Software Innovations together on hawkBit. And in Benjamin's slides, you can already see hawkBit is only mainly focused on the back end. On the client side, where the magic actually happens on a software update, it's very domain dependent. If you're updating a car, if you're updating a small sensor, if you're updating a gateway, it's always different. There are different operating systems on the devices. There are different ways to update software, maybe with the reboot, without rebooting. So hawkBit mainly focus on the backend because we figured out that on the backend side, the update process looks always the same. If you're updating a car and a sensor, it's just like when is the time and which version of software you wanna deploy on the device, right? And this is mainly what hawkBit is. So it's domain independent backend solution for managing software rollouts. It has two different APIs to connect with. To talk with devices. It has a direct and an indirect device integration. I will show it in a demo later. And this just means some devices can have an extra channel to the backend for software updates because they want to keep this channel only for software update and they don't want to share it across with other telemetry data going on the channel. So they can talk directly to hawkBit, and it's a HTTP PAL-based mechanism. And we figured out, and also in all the white papers you see on Benjamin on the Eclipse IoT webpage, is many people have already an IoT solution and they have already decided which communication channel they use. So some people using Lightweight M2M, some people using HTTP, some people using MQTT. And hawkBit doesn't want to adapt all these connectors to hawkBit itself. So what we have like a device integration API, which is event-based, based on AMQP, and we hopefully, when Hono is coming and support command and control, we hopefully can integrate with Hono, and you can just like deploy software through Hono to your device management solution and to your connectors. And because it's a back-end environment and about the scalability, we are building it based on Spring Boot. So if you're familiar with Spring and the capabilities of Spring, properties, environment variables, and all the configuration, you're very quickly in hawkBit code. So this is just a roughly overview what hawkBit offers. To you, we have to the northbound, we have the graphical user interface. We have a Vaadin UI shipped in the open source. So it's open source. You can adapt the UI. You can style it. This is what we do at a commercial product. I will just show you the basic example of hawkBit, which has rudimentary theme on it. Everything you can do in the graphical user interface, you can also do via API. So you can have we have products for a project, for example. They're using Jenkins to build their device software stack, and then using our API to directly push it to hawkBit, and then start a dev at home, for example, deployment on a field test basis. So every build is deployed on devices. Here are the two device integration APIs. To the left is like the direct, to the right on your side, the direct device integration. It's HTTP based and it's a PAL mechanism, so the device is asking for new devices. This is very, very easy to start with. But as I mentioned, many people out there are already having connectivity solved, and they have many device management protocols like iterative, which offers much more than just software update. They can make use of this device management federation API. The main features of hawkBit is the device and software repository. We are not a device management, but software update is mostly part of the device management. So if you're looking at device management protocols like M2M, they have a part how firmware updates is done in with M2M. We have artifact content delivery, so maybe some of you ask why we don't just start an FTP server and devices can download it from the FTP server. hawkBit is doing a little bit more than just having like the download. We also do authorization of the download, so if this device really is allowed to download this artifact. So that's a little bit more. And we have the software update and role management, which I'm showing in the demo, like grouping devices together. And one main part of the software in hawkBit is software is not a single file mostly. So you have metadata on your software. You want to know if this is a operating system I want to update, if this is an application, and if you're looking at a gateway, there is a stack of operating system. There's Linux on it. You need to update Linux. You need to update your application. You need to update probably your JVM if it's running on the Java stack. So in hawkBit, you build a distribution which is based on different software modules. We'll see it in the UI. You need to set up like a metadata, and you can have many files in there. But all the metadata you can maintain in hawkBit, like which version of the file. Some people maybe use the file encoding, like with Dash, and this is like Maven does it. But it's getting hard to maintain if it's a flat file system. And for sure, you wanna group the rollouts together, and I think the demo will show it better than the slide does. But in general, what you want to do is you want to start rolling out your software, and in case of there's an error, maybe you did a mistake or there are files broken, you probably want to stop immediately your rollout. So it should not like rolling out all your billion devices. So it's in a small amount of group. You want to try it out, test it, and then you say, okay, if it's fine, please continue. So, and then we have like a easy way, which you can extend for sure. It's an open source software, but we have an easy way to do this. And we have an automatically pause shutdown mechanism, which in the case of an error threshold, it will stop your rollout. And I think the best thing to show something is a demo. And normally software updates demo are not that, but I don't know, you cannot see mostly on your devices, you cannot see anything when something is updating. So I try to do a little bit, at least, to show something that something is happening. So I have a Raspberry Pi here, and I'm not a hardware guy, but I have some LEDs wired up here on the Raspberry Pi, and what I can do with hawkBit, I don't need to flash the whole Raspberry Pi. I can also deploy Python script, for example, to controlling Raspberry Pi, right? It doesn't matter if you deploy scripts on it or deploy a whole operating system. And this is not replacing Eclipse Smart Home, so Kai, don't worry. Smart Home is more powerful in controlling probably LEDs, but this is how hawkBit looks like. Hope you can see it well. This is when you're logging in, the first few you see. And as you can see, I already have my Raspberry Pi setting up. It's hard to read, I guess. And this Raspberry Pi is just polling every 10 seconds because I told him like polling it. The server tells him how the device is, how often they should poll a day. You probably set it up a day. So if I delete the device, it will show up immediately because every 10 seconds it will poll again. Probably missed just. So hawkBit allows you to easily update single devices. For example, it's very easy if you are under development or if you want to show something. It's very convenient to just update single devices. I'll come to more details what is in the update. Because the Raspberry Pi is polling every 10 seconds, it's very quickly, and I just dropped the all it's probably not seeing in the last reel, but drop all on LEDs script, and it's just like, yeah, showing all LEDs. If you have more devices, hawkBit also ships with a simulator, and we just go with, I don't know, with some devices. And they are using the AMQP API, so I can switch which device interface they should use. And I just generate 200 devices over the AMQP push API, and they're all set up here. So it's very, if you have many devices, and you can see hawkBit is just flattened them, so there's no we get asked if there's a topology. I have a car and I have many control units in the car. How does it work? Or I have a gateway, and behind the gateway are different sensors. hawkBit just flat them. We don't have a topology management. So you can decide in your project if you just show up the gateway, and the gateway knows where the software needs to be routed and deployed, or if the devices are in there with the gateway flattened. So it's very, very, so you need to distinguish what is the Raspberry Pi and what is simulated, for example, in our demo. So what I can do, and this is only one thing in hawkBit, only one way to do it, is to how to find my device back, what to deploy on it. So I can tag them, actually. So I can tag my Raspberry Pi. So if I want to just deploy software to Raspberry Pi, I can tag them and search them up. So all you can see here, you can also do over the API, right? And we have a much more complex way to finding your solution. I can use a DSL here and just like, actually I'm not sure what it called, the Pi. So give me all which have a Pi in the name or which are tagged or. So this is how you find your group where to deploy software to it. And this is one common feature you need, right? To find your development environment, your development devices, your product devices, all in one. And because we are running a little bit out of time, I just want to show you one of the main features in hawkBit, and this is actually the rollout. Like Benjamin said, it's you cannot download, you cannot tell everybody at the same time download the software. This will crash your system and crash your bandwidth. So what we can do is we can create a rollout, and you can tell which software you want to deploy on it in the rollout, and you can tell which devices are affected by it. And here you can use this DSR feature, and you can create like filters on it. Then there is a very, very easy way, and this is how we started. You can just say, I want to group them just randomly into groups. So if you want to just randomly into groups, I don't want to control when, where, which device is in which group. So, and we have just recently, and this is just from January, this feature introduced to have more flexibility, which device is in which group. And unfortunately, I didn't save my filter with the Raspberry Pi, but we just do it like this way. I can group them up and say, okay, I want to have 20% of devices in the first group. I want to have 10% of the left of the devices in the third group. And let's grouping them a little bit up. It also tells you there are some left devices which are not filled in a group, so you need to do something. So let's group them up. As I said, unfortunately, I didn't set up like my Raspberry Pi filter. I didn't save it. Otherwise, I would put the Raspberry Pi in an extra group, which is a defined group. And what you can do is like you can start the rollout immediately after the creation, because if you have 1 billion devices, it's calculating in which group needs to be device, and this takes maybe couple seconds, maybe a minute. So if we're saving this rollout, you can see it's created. We have 201 because we have 200 simulated devices. We have them grouped up in different sizes. doesn't make that much sense probably with 40. And our Raspberry Pi is in the first group. And if we start this thing, you can see that it's working like group by group. It's working like the rollout. And yeah, they're all off. At least this is working. And the simulator is responding very quickly. It's just getting an event, download something, and it's downloading the files which is in there and sending back. Everything is good. So the simulator is not showing that much. But you can see the grouping and the rollout feature. And because I'm running out of time, I would stop the demo here. If maybe there's a question out there, and if somebody want to see more of the demo, want to ask them more questions about hawkBit, I'm here the whole day. I'm here the whole week, so I'm around.
Can you show a little bit about the distribution?
Yeah, I skipped a little bit because of the sake of time.
Can you try it? Git control plus and make your font slightly larger?
We can try it. Does this work? I'm not sure why it's not that sharp. It's sharp on my screen. Yeah, weird. I said we are not only having files deployed on a device. We are putting metadata around it. So what I created a software module which is based on a type, which is Pi LED. And a Pi LED is just a keyword, so the controller knows which is running here. This is actually only a Java program which executes the Pi script. And with the keyword which is in there, the controller knows what to do with the files in there. So my Pi LED has a keyword which is Pi. And this is going down to the controller. And he knows that what is in these software module packages, and these files are all handled by this controller. So these are some meta information for the controller to know what to do with these files. I could create here another one, and I just say, OK, I want to have a Pi LED software module, and I think I have a Blink script. I can put metadata in there in the software module, and I can put as many files I want in there. I can do diff files, for example. I can do different versions, which a controller knows, OK, when there is this version in there, I take this version, or I need diff file from version 1 to version 2, but I need version 1.5 in between, whatsoever. And you can just upload them to, I have files somewhere here, a Blink. You can just drop them. And as you can see, hawkBit is very carefully about checksum, because if you're deploying corrupt files, it's not that fun. So it also gives you all the checksum which calculated, and you can provide in the checksums, which are also included in then deploying on the target device. And if you want to package your distribution, which is only metadata within hawkBit, so this distribution set, it's only metadata within hawkBit, and it's not going down to the controller. This is just like making a release out of your software update, because as I said, you probably don't have only one file, or if you're doing an update, you want to update your operation system stack, you want to update your runtime stack, you want to update your application, you want to update maybe different bundles within your OSGI container, and this is not only one file, these are maybe 20 applications within the OSGI container. So what you're doing is like, let's take a smart home scenario where you creating distributions based on Eclipse, smart home, release, and version 1. And in this distribution set, you can then put software modules in there. And because this is also based on a specific type, you can tell what this type needs to be in there. So you always build in the correct software for your stack. So, for example, if you want to create an smart home release stack, it's always based on, for example, an application and operation system software module, and could have many applications in there. And you can say, OK, this must be always in this release. And only valid distributions are then deployed to your devices. I hope this gives a little roughly overview what is metadata around software modules and distributions are.
Yeah, no questions, I'll talk to you.
Yeah, I'm here. I'm around.
And there's actually a coffee break coming, so like,
Yeah,
you
then
said you'll stick around. Yeah, I think we'll take a short break. We'll be back at 15, 10:15. Sorry, 11:15, quarter past. Thanks very much, Mikael. That was a
thank you.
demo.
Thank you very much.